Good evening, all, and welcome once again to the Overlapping Magisteria channel. So I've been toying about whether or not to bring this to people's attention for quite a while now, but everyone knows that the speed of light in a vacuum, or roughly about 3.0 times 10 to the 8th meters per second, is the universal speed limit. Nothing can pass it, right? Well, according to a recent paper that was published in the JETP Letters, that was talking about the detection of gravitational waves that LIGO made some time ago, has basically said in their abstract here that there is a way that they could actually place a bound of a speed bound on the gravitational wave speed. And what they found interesting was that apparently the actual speed of the gravitational waves was around 1.7 c, or 1.7 times the speed of light. Now, I'm actually going to go into the paper here to see whether or not they give an explanation for why this is. Please bear with. This is going to take a minute. And yes, they say in the abstract, and they go into greater detail in the paper, but with the abstract, they actually say, we point out that the observed time delay between the detection of the signal at Hanford and at Livingston LIGO sites from the gravitational wave event places an upper bound on the speed of propagation of the gravitational waves as CGW less than or equal to 1.7 in the units of the speed of light. So apparently they also compare it with some cosmic ray releases from the black hole merger as well. But because of the fact that this is model independent, and also apparently they compare this result to specific constraints from pulsar timing and cosmology, this is interesting in the sense that we may now have the first evidence of whether or not something has actually bypassed the speed of light. Granted, it's only a wave propagation, but this is still something. It means that information has traveled FTL. So what does this mean for the classic laws of physics? Well, truth be told, I don't know. But I'm kind of hoping that somebody out there who is watching this video will go through this paper and be able to find a flaw in it or find an explanation for why the gravitational waves are propagating at a speed that, according to Einstein's theory of general relativity, should have been unsurpassable. Or was it special relativity? Either way, the point being is this is the universal speed limit, so it should not have been surpassable by anything. There is one explanation I do kind of like with this, and that is for this paper here. This paper, which was published in the Physical Review D a little while ago, suggested the idea that there might be shortcuts in extra-dimensional space, which could be taken by sterile neutrinos. But they also proposed in this paper as well that there might be a way for gravitons, particles of gravity, to take extra-dimensional shortcuts in a way that might appear to travel faster than light. Now, with that in mind, it's one possibility as to how this is happening. But also there may be other explanations for this that haven't been considered. For example, there may be a glitch in the temporal detection between the two locations. There might be a computer error accounting for this. Remember the faster than light neutrino thing that was detected from Gran Sasso, Italy, and they determined that to be a GPS synchronization and a fiber optic cable issue. So I'm thinking that future experiments, maybe with a more sensitive version of LIGO or the LISA interferometer, which was due several years ago to go up in space, might provide more data as we collect more gravitational wave signals, and that might shed light on this theoretical idea, and we might be able to empirically test whether something is faster than light. But anyway, considering that the paper in question that I was talking about was approved for publication just this past year, it's relatively recent, relatively obscure, but it is a hypothesis I think worth testing. Because if we can determine that gravitational waves do travel at c, well, then that would provide a little bit more data confirming Einstein's theory of relativity, as this is supposed to be the great last prediction of general relativity that was yet to be confirmed. And if it does turn out that they're moving FTL, then maybe it might show that Einstein's theory under certain circumstances is incomplete and may require further elaboration. Anyway, just some food for thought for everyone. Thanks again for watching this video, and I hope that somebody will take this ball and run with it. Let's see where it goes.